name's Andy Reitano, and I'm going to talk about how we created a real-time collaborative artboard using the old ANSI DOS character set. Yeah. So welcome to BuzzJS. I'm honored to be the first speaker. This is actually the output of a collaborative thing we had done. A few of my friends got on, and we just started hacking away, and this was the end result, so I captured it and put it here. Pretty excited about today. There's a lot of great speakers, so... I'm a Microsoft technical evangelist. I've been working here for about 6 months. But before then, I was an electrical engineer for about 10 years. And I mostly work on circuit designs for classic computers. So on the left side, you'll see one of the arcade games we worked on and some circuit boards for like Sega Genesis cards and NES cards and things like that. The top left one, I used to have a professional headshot, but then I put that picture in to remind myself that like I'm always sort of going to be kind of a roadie moving equipment around no matter what I do. And that's my call sign for any ham radio people in the audience. Just going to play. Oh, there we go. So this was like the first demo that we had run, and a few of my friends popped on, and we were just playing with it. And this is embedded in the browser, and basically you're able to log on and commit certain glyphs, select a palette and start drawing live. So anyone could just go to the URL and start drawing. We can run a live demo later, but I'm going to talk about how this all came to be. So a bit of backstory. I tried web programming like 5 years ago, and I was sort of grumpy about it. I didn't have a great experience, but it was mostly because I had worked with a lot of low-level code over the years and a lot of big scaling code also. So I'd worked on this hardware mod for the original NES. And what it is it's a circuit that allows you to read and write RAM in real time while the console's running. So the game doesn't know anything's wrong, but on your computer you can go in and start modifying values and reading data. And it's like 2 kilobytes of RAM. And always when I speak to like younger crowds, I'm like, that's like 16 tweets. That's like nothing. I have to try to give them some perspective. So, we naturally started playing with this idea that, hey, you can take old games and start extending them. So this was a game called Blades of Steel that was like this hockey game that we used to play really competitively. And we added like this Jumbotron. I don't know if the... So, I mean, it's silly, but, the game's completely unmodified. And we're able to pull data and project them here. We actually rewrote this in a JavaScript library. I think we used Pixie for this. And, if my cousin and I had like the choice between the hot new game and this siren peripheral, we would have definitely picked like this crazy siren. So, we started doing things like Contra, where every time you shot, it would like flash muzzle flare over the room. And what was kind of interesting about it is it was originally intended to be a modification for debugging homebrew software. So we had like this live hex editor. So we started playing with the idea where we're pushing the values out of range. So now in Castlevania, you're like whipping Medusa heads and you're doing things that the game engine shouldn't do. So I went down to an event called Fantastic Arcade. It's down in Austin, organized by a group called Juegos Rancheros. And basically, it's an indie development celebration. So there's a bunch of different speakers, development talks, and it's an Alamo Draft House. So it's a theater with table service. There's a new one in Brooklyn, right? So basically, you're sitting around and watching like some of the best developers speak about their crafts, from art, music, whatever it is. And you're like eating nachos and drinking margaritas at 2 p.m. in like an air-conditioned theater in the middle of Austin. It's a great time. So I was down there and I had that console to show my game. And this guy come up to me and he said, hey, I'm into NES stuff too, but not the way you would typically think. So he opens up his browser and he's like, I made this WebGL shader to simulate glitches. So, imagine you have like a dirty or dusty cart. What kind of glitches would you have on the NES? So these are kind of faithful in the way that like they're 8x8 tiles that are getting scrambled around. I said, whoa, that's pretty cool. And he shows me this thing. And if you ever used QBasic back in the day, there was a thing called Gorilla.Bass, which was like this game where you threw these bananas with this velocity. And to me, that was like the first open source game because you were actually like running it in QBasic. But he made this thing, and I asked him, how do you get multiplayer like that? And he's like, oh, you just, Socketio, you go to the URL and you're in. And I said, how many users have you had? And I think he said he had like 200 and the whole screen was just bananas, like flying around. So I was in disbelief. I was like, you could just log in and start doing that. I had no idea it had come that far. And then he shows me this other game, Narwhal Joust, I think it was. And same thing, you just go on, you type your name and you're off. And I'm like, whoa, this is awesome. I encourage you. His name's Zach Johnson. We ended up working on this Nest Spectre project that I'll speak about. I highly suggest you go to his site. He's working on a game called Joggernauts right now, which I think is also written in JavaScript, which is great. But really talented guy, and has taught me a ton about web programming because I'm new to it. So one of the ideas we had for that console where you can like kind of muck with the values was, hey, what if we like gave that ability to the audience, right? What if we gave it to a bunch of people and someone just, says they're so good at this game and they're running along and you take away their lives or you start making them jump. And he said, yeah, no problem. And I was like, okay, we'll exchange emails and we'll talk later. And he goes, no, we'll do it right now. He goes, then he pops open, it's Sublime Text and I haven't even used Node really at this point. So he puts this thing together. And in no time, I have a panel to speak at in 48 hours. And the next day, he goes back to his Airbnb, hacks away, comes back, and he has this, right? So the idea is you go to your phone, your browser, and you can start clicking these buttons, and you start affecting a real Nintendo. So we had a guy who like speed ran Contra. He's like an expert, and he's playing, and everyone's on their phone, just like kind of screwing with him. But I was just blown away. I mean, I keep saying it, but like in my world, there's a lot of pre-planning and structure, for a lot of the apps I develop need to be kind of very functional, very critical. So the fact that you can just kind of whip this thing together so quick, I was just blown away. And the idea that you didn't need an extension or anything just to start talking to other players, no IP address, no client, no app, nothing, just a cross-platform, any browser. This is when we kind of knew we had something, right? If you're familiar with Contra, you're supposed to like bust into this wall like Rambo and, run through the base. But somebody hit the scroll register and jumped over the wall. And now we're in like the void, right? So I think we left this picture in just to kind of prove that we're still hacking away on it in the middle of, like we have our talk in like 10 minutes. Right here, you can see the screen there. And it went great. And he'd done it in, like I said, less than 48 hours. I think it was a day and a half. So, since then, I've been deeply, deeply intrigued by, the amount of libraries available on Node, the fact that you can whip this together so quickly. So a bit about the structure, if you're interested. At the NES console, and I'm speaking to it over USB, funneling the memory commands for read, write, and, at the time we had it polling a JSON string from this Node server. And then over Socketio, all the clients are able to send commands, and this just kind of funnels it over to the script, and it'll write to the console. And we like to think that we have actual ghosts in the stack, because we love the idea that the console was haunted, because the games were unmodified, but people didn't know what was going on. We used Azure Web Apps to launch that app, Node.js, Socketio, and Express to serve up the web page. So this is a video of it running. So the game like totally descends into madness, and it's at the hands of the audience. And it was kind of a fun social experiment because what you realized was that people were really cruel at first and started taking away all the lives. And then they felt bad and they started going back up. Then they felt really cruel again, but they would go so hard that it would underflow back to 255 and give them the most lives. But we had a few demos where, again, we whipped them together really quick. This thing where you would vote on the next Tetris piece, and then the audience again would give them all lines and then a block right before you made your Tetris. And I can show you the interface at the end if we have time, but just the fact that we got it together so quick was just amazing. So I decided to come back. When I came back from Austin, I was feeling all inspired and saying, I'm going to try my hand again. And we were trying to think of other ways we can collaborate with users, and I wanted to make a real-time piece from scratch. I'm using a dark theme because I'll explain with BBSs, a lot of the stuff is DOS fonts on black backgrounds anyway. So has anyone ever used a BBS? Yes. That's like still way more than I thought. So the bulletin board system was real Wild West. It was a really amazing time. I was a teenager at the time. And the idea was that you can log into a computer, and I mean a one-to-one connection. Your phone dialing into somebody's computer, and you're leaving messages almost like a dead drop. And you're on, so no one else can get on unless the advanced users would like beg their parents for a second phone line or something like that. But you'd be logged on, and you would leave a message, and you would hope somebody would respond, and you would log in again in a couple of days to see if anyone did. You could post files. And you didn't know where you were ending up, right? It could be some like, a lot of these look, like cigarette burn keyboards, just a bunch of equipment, gear, as many, wow, 100 megabyte hard drive. Whoa, this BBS rules, like amazing. And you would dial directly in. But a big part of this scene was this idea of ANSI art, and that's using the original DOS character set and the original glyphs to create like these beautiful art pieces. And of course, they were very small because you're just sending essentially every character is represented by a byte and every color is represented by an escape code for a byte. You're sending just a few hundred bytes to send this picture here. There's no compression or anything like that. But I really like this one here, which is, it wasn't just like, cracking groups and crazy computer hackers or anything like that. It was also like computer show for the Palm Beach users group at the high school cafeteria, featuring a demonstration of the internet. So you get like these beautiful woven like tapestries of these characters, which usually are pretty ugly on their own. And I mean, this thing goes on for a while, but people are still doing this art, and it's basically using these core 4 glyphs, which are like 4 dithered pieces, like a solid color, into a half tone, into like quarter tone, into maybe an eighth tone. Is that a thing? I'm not sure. So I've always loved these kinds of interfaces. Like even the old DOS interface having, realizing that the scroll bars were made of these characters, building a functional GUI out of this primitive character set was something I always liked. And for every cheesy sci-fi movie, there's always some terminal with a bunch of ASCII, like the map, right? We ran a BBS from 2013, 2015 to invite people to our stupid parties, but you would just telnet in, and just wanted to put these up because there's some, rooftop barbecues and, I don't know, electronics discussions. So we got our ham licenses with a few of the art pieces we did. So why'd I use TypeScript? So TypeScript, the official statement is, and I'm going to go into each piece of it, kind of break it down. How many people in here have used TypeScript? All right, great. I'm new to it, but I've really been enjoying it because when I came back, I first used JavaScript, and I learned a ton, but there were things about TypeScript that really appealed to me, and I'm going to explain why. So TypeScript is a type superset of JavaScript that compiles to plain JavaScript. And that is kind of like a loaded sentence. There's a lot of information about what that means, right? Like there's a lot of information in that sentence. So we talk about a type system, right? So now, if you're familiar with object-oriented programming, you have a class of student. You can create a class and it can have properties. It can have methods. It can have a constructor. You have these like clever little tricks where if you specify your parameters as public, they can exist as accessible properties. So it's almost as though you made a public first name, middle initial, last name in the class. You can use interfaces. Interfaces are really handy. You create code contracts, right? So talking about an interface person, if you have a class that satisfies having a first name and a last name as a string, you can pass this interface in, and you can have multiple types of this interface. So, for instance, greeter is expecting a person as its parameter, meaning it's expecting the interface. So we create a student, which can be passed on the greeter because it satisfies the interface. It has a first name, it has a last name. So then you can have something like staff or employee or something, and that can inherit this, maybe not inherit's the correct word, but it can abide by this interface, and then you can pass it into functions. So when I say a superset of JavaScript, I mean that all your JavaScript code is compatible. So I'd written this ANSI arena thing in JavaScript at first, just pure JavaScript. And when I say a gradual typing system, I mean that you can take your existing code and start to refactor it and only introduce typing where you want it or where you need it. So you can refactor old kind of ugly code and start making it scalable. You make them into components and start, making everything modular so you can build this big, piece. So here's an example of, on the left side, I have TypeScript on the top piece. So here's just my player class from my ANSI arena. I just kind of cribbed it from there, and JavaScript code on the bottom. What you'll see is when I run it through the transpiler, the TypeScript code is getting converted into its equivalent JavaScript code. So they're functionally equivalent. But any JavaScript code that doesn't use any typing just gets passed completely through. You can see it on the bottom here. Just straight code goes right through. And what's kind of interesting about this, and you know, I don't know the implications of, say, you know, ES5 versus ES6, but I do know that if you have your if you're using a transpiler, your TypeScript remains the same, but you can set a new target, and then I believe you can invoke bleeding edge features. But you can always go back. You can always fall back to a functional equivalent here. So your TypeScript remains the same. And I think that's really interesting. One thing I like is that since you're running kind of a classic a code compilation, you're actually, it's done automatically the way you set it up. But when you do transpiling, you'll catch errors before you ever run them in the browser. You still need a unit test. That's not going to eliminate that. But you can catch a lot of problems very early on just by running this. You know, for instance, now when you have a type system, you can start using Intellisense in Visual Studio Code, which I'll go over. It lets you explore libraries without any documentation on hand. It lets you fulfill those code contracts and get immediate feedback as you're writing your code. So I was going to talk about definition files because when I first started playing with TypeScript, I was still in TypeScript 1. And TypeScript definition files allow you to expose external JavaScript libraries. And I'd written a few of my own because I was using a deprecated version of a library, and I had to write my own kind of piece. So for an oddball like node library, I had to write my own definition file. But what was interesting is if you go to GitHub, there's Definitely Typed, which was a repository of up-to-date pre-made definition files. And it's a great example of like a community effort. I forgot how many contributors they have, but it's in like the thousands. And now, as of TypeScript 2, you don't need any tools apart from NPM, which thank God, right? We don't need another package manager. NPM is fine. So you simply, I mean, it might be too small to read here, but for this project, if I do an npm install @types/socketio, and you can even append, you know, -version on there, you're going to pull down the TypeScript definition file directly in, and this will be in your packages, right? So you can pull it down, and now you have full Intellisense through Visual Studio Code. I love Visual Studio Code. I think it's one of the greatest products that Microsoft has put out. It's a lightweight editor. A lot of people confuse it with Visual Studio, but it's more akin to, say, like a Sublime Text or an Atom, right? Where you have build tools and you have an environment with code hinting and Intellisense and everything, but you're not installing like heavy compilers like C# or anything. There's extensions for everything. You can bring this almost up to Visual Studio level IDE, but for quick code or a lightweight application, this thing's amazing. It's cross-platform, which I think is great. You know, this is something I always recommend to beginners because it's free, it's cross-platform, it'll run on your Mac, it'll run on Linux, and it runs great. It's open source. I believe it's actually written in TypeScript, which is interesting. Full Intellisense support, I had spoken about before. Built-in debugger. This is something I love for beginners is these two features on the bottom. It has a built-in node debugger. So if you open a folder, it's aware of your packages.json, it's aware of your app.js, and you hit play, and you could drop a breakpoint right away. I mean, you're downloading one thing and you have a full development environment. And then source control, there's a built-in Git repository manager, and there's a GUI there. And the idea with that is a lot of people are scared of Git. You know, I know there's a lot of fancy front ends and everything, but when I recommend to a beginner, you know, just to get an idea of how it works and how, you know, what a commit is, I love starting them with Visual Studio Code because it's built right in. It's already aware of your change files. You can track changes right there, and you can do your commits right through it. So I spoke about Intellisense, and the thing is, you know, if you opened up a file in, say, Sublime Text or even Visual Studio Code, and it really wasn't aware, it's going to take its best guess based on the previous the code that already exists. But it's going to give you too much information. Once you start introducing typed structures, what you end up doing is giving the editor some context. So now it can give you useful information. It can tell you right away, hey, this function's expecting this parameter, and you don't need to go back and check. And I know that this exists. There's several development environments where this exists, but I feel like getting up to speed and getting set up takes like 5 minutes with this. A few of the libraries that I had used. So I'd used Socketio, which is, again, real-time, bidirectional event-based communications via WebSockets. And basically, it couldn't be easier. I'm going to run some example code where, as simple as an emit or a broadcast, you could talk to one person or everybody, and then your actual callbacks, you bind to the message you define. I used a thing called Jwerty, I guess is how you pronounced it. And it's just a bit more powerful of a key press manager. So you can have a combination of strings or like a range of letters, and you can have callbacks that way. So I'd use this beyond the basic like dot key down and key press. I found it was a lot easier to work with. And I used Pixie, which is pretty incredible. It gives you a canvas. It's a 2D WebGL renderer, but it supports lidding from textures. And I'll go over what that means, but specifically for 2D art, it's really important. So our hero, our little avatar, and you may recognize this one. Yeah, if you ever opened up like an EXE or something in a text editor and you just see a bunch of like poker symbols and this little smiley, it's because ASCII, the tile that lives at ASCII 1 and 2 is this kind of hollow smiley face and this solid smiley face. So a bit more about how it works, right? So here's Jwerty key. We're saying binding the function to respond to numeric 1, not the numpad. When we do that, we tell it to emit the message over Socketio, the draw, and we're passing the player's position X and Y, the tile number we wish to draw, the color, foreground color, and the player's ID. So this will pack it in, it'll serialize it, and then on the other end, when it receives it, you can deserialize it really easily. So now on the server side, I have a function that's bound to wait for this draw message. When I receive this draw message, I'm going to broadcast it back out to all the clients so they know that it needs to be drawn. I'm also going to update my board state so that way if a new player joins, I can feed them that information. So it looks something like this. Sent the emit to draw, goes back up, broadcasts it back out to everybody, including the player who sent it. So it's kind of like a validation that it was a valid command. They didn't go off the edge or you didn't ban them. And you'll see here that it placed the glyph and advanced the character by 1. And again, the board state is kept in constant check. Then the reason for that is, if you're not there to witness the packet, how do you know what the artboard looks like? So you keep it on hand and you can sync new clients as they join in. So for instance, let's say I had a URL where I wanted to clear the board. Game server is calling its own clear board, which is just a nested for loop that's going to run through the whole array of tiles and set them to 0. That's going to broadcast a clear board to all the clients. And it's as simple as that. You're calling a broadcast.emit from the server. It knows to send to everyone but itself. Then internally, the clearboard function is bound to clearboard callback. And then I can call any function that way. So we have the same thing here with, let's say, a client joins late, right? Socket.emit request sync. Whoops, it should have been sync board. Sorry, I copy and pasted right now. Socket broadcast emit sync board, game board, the color map. Comes back to the one client that it cares about because I'm calling .emit. Socket on, I have the nested for loop here. It's going to draw the tile and bring you up to date. So this sync happens when you log on. Any new player will come in and do it, and then any packet after that they'll witness, so their board will be up to date. So this sync is actually kind of large. I mean, not large, it's like a kilobyte or something, but you wouldn't want to be sending it all the time, I suppose. So we only send it on join. So here's an interesting concept that goes back sometimes. So if you imagine each one of these symbols and you wanted to draw them and you had a texture, you would you could have 256 of these little 8x16 textures, but it wouldn't make much sense. You can do a thing called blitting. And I'm not sure what it's called in web land, but Pixie calls it a frame. So the idea is that you can load this one texture at runtime, and you can specify a tile number. And if you know how many pixels wide, how many pixels tall, how many tiles per row, how many columns, or how many tiles per row and how many rows you have, you can actually determine and pull out the graphic data from this one texture. So if I had tile number 1, I'm modding it by the map width, I'm multiplying it by the amount of pixels, and then for the Y, I'm dividing it by the map width, and knowing that it's going to round down, right? It's an int, and I'm multiplying that by 16. So that would give me 8 over 0, and then 8x16 sprite. So I grab that frame, and now I can commit that to the buffer. Same thing here. Let's get a little more advanced. I could have made a long row of characters, like some crazy 4096 by 16 bitmap, but you can do any texture if you just know how many tiles there are. So again, we're going to run through it. 176 mod 64 times 8. That's going to bring you over 384 pixels. With the Y, I know that's going to be 2 down. So 176 by 64 times 16 will give you 32. You go down, and now you can pull that little dithered glyph into your piece. So I'm going to run a quick demo. Whoops. I need to stop this presentation. There we go. Whoops. It's not right. It's okay. So it might be hard to see. Let me update the colors for the avatar here. You can see the live update between the two. So I'm moving this little guy. Oh, it's gray. It's kind of tough to see. They're randomized colors. But I can commit tiles on this side. They'll appear here. I can update the palettes using the square brackets. And then likewise with the first player, whoops, I could bring this down here. So we've had a lot of, oh, someone else is in. I knew this would happen. Keep it clean. So the square brackets will change your palette. 1, 2, 3, and 4 will give you the 4 glyphs, and then the 5 through 9 will give you these kind of half pieces to, if you want a little finer resolution. Uh-oh, here it comes. I tell you what, I'm going to look away from the artboard, and then we're going to come back to it. We'll see what we get. But, you know, again, I just can't stress enough how powerful the idea is that I just hit a .admin. I just hit a .emit, I hit a .broadcast, and I'm talking to everybody immediately. There's no login, there's nothing. Right now, this supports, I think we had like 22 players on it at the same time. And this project's open source, so I'll be putting the link up at the end if anyone's interested in downloading and playing with it. It's real simple. And in fact, if you do go on, to play with Visual Studio Code, you just do a file, open folder, and you're there. You just hit play and you're good. Localhost 3000, you're ready to rock. I wanted to kind of capture the spirit of the original VBS systems in that it was really a collaborative process. You know, if it weren't for the users, there would be nothing. It would just be a computer in the room. So, you know, there was a lot of thought that was passed in between each piece. I'm glad this is working well, by the way. I only tested it with a few friends. And as far as the NetSpectre project that I was talking about originally, I can pull this up. You know, we had a working console where we can fire out the admin again with a broadcast. I think there's actually a ominous gong that plays when... There it days. And that's really funny because we had put that on. We had 100 users in the room. We hit it, and all you hear is dung, 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 and it all starts resonating around the room. And we're like, yes, so good. But it was just so simple. So I encourage you. You guys might already know about all this, but this was really something that I couldn't believe. And then as I delve deeper into NPM, and start looking at some of the packages they have, it's just been kind of a really incredible experience. So I was kind of hard-nosed about the whole deal because I had some initial problems with JavaScript, but that was on me. I'm really enjoying playing with a lot of these interactive experiences because I can't think of another way you would feasibly do it. No one wants to download an executable. No one wants to download an app. You can immediately create an experience like this. Keep drawing. We'll check in after Q&A. So, some future improvements that can definitely be put in are touch controls. That's not something I've explored yet, but I realized that would have been fun if everyone was on their mobile, but you definitely would have crashed it. Some more efficient network code. The avatars are kind of superficial, so I would update them on a tick instead of all the time or every time somebody moves. And then an actual palette selector with controls and feedback and things like that. But I was able to put together this project in 2 days. It was, these kinds of things are so rapidly prototyped. Let's see. I believe that's it. So I'm moving over the repository to GitHub. It's on Bitbucket right now, so I'll move it over by the end of the day. I'm just going to clean up some of the TypeScript files, and then we're all good. So, any questions? Yes? I didn't, but we only pushed...
Andy, can you just remember to repeat the question?
Oh, sorry. Yeah, he was asking about scalability of the app. If I had any problems scaling up this application, and the truth is, I think I had 12 users in it at once, but it's really not a lot of data firing over, and it doesn't matter when it gets there. And I could definitely be a lot smarter about how I'm sending these packets, but I believe you could probably scale it up pretty large, and especially if, like I said, the superficial elements you were taking, and you're taking these superficial elements and not updating them all the time. So if you had 128 users, if they're all drawing at the same time, it's a lot of data. But if they're all moving at the same time, it doesn't have to be a lot of data because you don't really care where they are. You just want kind of a general thing. You could even move them only after they draw, so you can kind of see where everybody is. But I haven't had a problem yet, but I actually haven't pushed it yet. Anybody else?
We can bring a mic over to anybody that has any questions if they want to ask.
All right, let's check the board. Oh.